Hi, my name is Bernardo Guzman, and this is my presentation for CAP 2, Fate of Lactate at Cal Baptist University for Kin 516, Advanced Exercise Physiology. We're going to compare, or we're going to talk about the difference between lactic acid versus lactate. They are thought to be the same, but are not the same byproduct, and the chemical orientation, as seen here, shows that they're not the same. One has one less hydrogen, and one has one more hydrogen. Coincidentally, one will lose that hydrogen in order for the other to be used later on as energy for the muscle through a whole other different system compared to the Krebs cycle that we talked about earlier on in the semester. Lactic acid releases the hydrogen during anaerobic glycolysis that leads to the byproduct of lactate. So anaerobic is the key word here, because that anaerobic, meaning no oxygen, is going to be important to how we use energy later on compared to the normal Krebs cycle that we talked about earlier. Increased blood lactate and exercise. So generally, when there's low to moderate exercise, blood lactate is removed at the same time it's produced during exercise. And the key to that is the need to be breathing. Excuse me. You have to be able to inhale and exhale and breathe during exercise in order for lactate to not overaccumulate. This changes with increased intensity. Lactate removal becomes harder, which leads to the change of aerobic glycolysis, oxygenated, which was done earlier in the video that we did previously, to anaerobic glycolysis, which is no oxygen. And basically, this illustration here kind of describes how the muscle goes through general glycolysis in its muscle through the Krebs cycle, and eventually ends up with the substrate of lactate, which then gets released and reabsorbed into the liver, and lactate is used to create pyruvate through the Cori cycle to create new glucose known as gluconeogenesis, which then sends the glucose back out into the body and reabsorbed into the muscle to create muscle movement or exercise based off of the intensity, based off of the increased intensity. This illustration kind of just reinforces the path of lactate, and we're exactly what we're talking about in the main title, the fate of lactate, and how it's used to make glucose in the liver via the Cori cycle. So we reoxidize pyruvate, being that it didn't have oxygen, because we're not breathing at the time of this increased exercise, because we are probably out of breath and we're probably testing our overall limits, physical limits. Basically, lactate and NAD+ creates pyruvate. This pyruvate, through this process, is known as lactate dehydrogenase, which is favored through lactate. This creates gluconeogenesis, the recreation of glucose. And the heart can use lactate, not for the whole time, but for a sustained period of time, which we'll talk about later, as far as performance expectations and how it affects the cellular level of having a high level of lactate in the bloodstream. We're going to talk about a little bit about the lactate conversion, and when the muscle capacity is reached for hydrogen, the NADH can't accept anymore through normal glycolysis, known as Krebs cycle. Oxygenated, meaning you can't convert or uptake these hydrogens through normal breathing. So the pyruvate gets sent through another pathway, as described earlier in the presentation, via the Cori cycle. Due to the decrease in oxygen during intensified exercise, as I said earlier, pyruvate take up the excess hydrogen with lactic acid, which then becomes lactate dehydrogenase instead of the acetyl-CoA in aerobic glycolysis. lactate threshold increases in trained individuals who have higher ceilings that they need to reach. Um, is there too much lactate? Is that ever a bad thing? Well, I think there is. With increased pH in the blood due to, this is also known as acidity, fatigue and discomfort will begin to occur overall throughout the body, and particularly we're talking about exercise, so the muscles tend to feel those muscles become a little heavier, a little harder to contract. And because of this state of decreased oxygen overall in the body, performance and muscle function can be affected. This kind of limits your overall physical performance. Now, this hindering of the ability to not be able to perform can be trained, and with trained individuals, their lactate threshold will be a lot higher because they are training for the intention to not feel this way. This is the only way performance can be sustained as you get older and your VO2 starts getting VO2 max starts getting affected by age. I have a diagram here that talks about speed versus lactate, and you can use a basic simple analogy as far as running the 100-meter dash. You take a track athlete and you put them through a 100-meter run, and as their speed increases, their lactate increases as well. Now, chances are there isn't a lot of breathing going on, so you're going to be going through the Cori cycle to replenish the energy that you're losing in this window. Thank you. Hopefully you guys got an understanding of where and what happens to lactate during high intensities, and what exactly happens when you reach that threshold, and that it can in fact be trained to be better and more efficient. Thank you and have a good day.